Let's look at this exponential function in a bit more detail. There's our basic graph, y equals a to the power of x. That's true if the base is bigger than 1. So that's what the curve would look like. If the base was in between 0 and 1, it would be a reflection of that in the y-axis. So there's our two exponential curves. The domain, we can see all real x. There's no breaks in the curve whatsoever. The range, y is greater than 0. There's no symmetry about the curve, so it's not odd, it's not even. Now, remember this from curve sketching. Y equals function negative x. The effect of function negative x, that was to reflect it in the y-axis. So in fact, the top one could be y equals a to the negative x, but when the base is in between 0 and 1, because it would be a reflection of the blue curve. And the blue one could be y equals a to the negative x when the base is bigger than 1, because the blue one is a reflection of the red one. So it just depends on what the base is as to which one of the two curves we'll have. Then our log function, what does that look like? Well, remember, logs are the inverse of exponentials. And we said inverses, if we were to sketch them on the same graph, would be reflections of each other in the line y equals x. So the range becomes the domain. Well, the range of our exponential was y is greater than 0. So the domain of the log function becomes x is greater than 0. The domain of the exponential was all real x, so the range of the log curve becomes all real y, and it would look like this. So the reflection of our exponential curve. That is if the base is bigger than 1. If the base was in between 0 and 1, then it would look like the blue one there. There's our two basic log curves. So let's use some of our shifting ideas that we saw earlier in the year to do some variations of that. If we had to draw y equals log 3x, using our log laws, I could rewrite that as log 3 plus log x. So what does that mean? I've got the basic curve y equals log x. Let's draw that in. What have we done to it? Well, we've got a vertical shift. That one's grouped with the y value rather than the x value. So we know we've shifted it up log 3 units. And so it would look something like that. What about y equals 2 to the power of x plus 3 then? Well, it's our basic exponential curve. This time the shift is grouped with the x. So we'd have a horizontal shift. And this one's shifting left 3 units. So slide that across, that would be 2 to the power of x plus 3. What about the log of the absolute value of x? So basic curve y equals log x. So function absolute value x, what did we do for that? Well, that was the one where we got the bit that's on the right hand side of the y-axis and we reflected it over. So it would look something like that. That was a quick one today. So 8F and 8G.